Hi, Jeff Procyse here to talk about Universal Apps for Windows. At the Build conference in spring 2014, Microsoft introduced Universal Apps to the world. Universal Apps, also known as Universal Windows Apps, are apps that run on Windows and Windows Phone. In the future, Microsoft has said that they will run on other devices as well, including Xbox. Universal apps are possible because of the high degree of convergence between Windows 8.1 and Windows Phone 8.1. The WinRT API, which forms the basis for Windows Store apps on Windows, is also present in Windows Phone 8.1, meaning the vast majority of the code you write for one platform will run without modification on the other. Visual Studio offers seamless support for Universal apps through a new solution type that allows you to share code and resources between platforms, but isolate platform-specific assets so that they compile only into the Windows project or the Windows Phone project. With Universal apps, you can write one code base that serves both platforms, but build UIs that are tailored to each platform's form factor. Windows 8.1 and Windows Phone 8.1 are similar enough that there's no excuse for building an app for one but not the other. In the old days, porting a Windows Store app to Windows Phone or vice versa was tedious because it required an almost complete rewrite. With Universal apps, the reverse is true. Once you have the app running on one platform, minimal effort is required to have it running on the other platform as well. Universal apps are the future of the Windows platform. Let's see what makes Universal apps tick and what the process is like for writing an app that runs on multiple devices. To create a Universal app, you begin by using Visual Studio to create a Universal app solution. That requires Visual Studio 2013 Update 2 or later. When you build a Universal app solution, Visual Studio produces two binaries, two AppX files, one for Windows 8.1, the other for Windows Phone 8.1. The Windows 8.1 AppX will run on any Windows 8.1 device, whether that's a desktop or a tablet. The Windows Phone 8.1 AppX will run on any Windows Phone 8.1 device. To the user, it appears that this is just one app. They go to the Windows Store, they find your Universal app, and if they choose to download it, the appropriate AppX gets downloaded depending on what type of device it's being downloaded to. If this is a paid app rather than a free app, once they pay for one version of it, say the Windows Phone version, then they're free to download the Windows version of it as well without additional cost. They've already paid for the app once, so they don't have to pay for it again. In addition, if your app supports in-app purchases, those purchases are shared across devices. So from a user's perspective, a Universal app is one app. It doesn't really matter that it is two different binaries. Most users will never be cognizant of that. One other thing you should know about Universal apps is that the term itself is a bit of a misnomer. We really should refer to these things as Universal Windows apps because while they're cross-platform on Windows devices, they're not cross-platform with non-Windows devices. In other words, a Universal app that will run on Windows and Windows Phone will not run on iOS devices or on Android devices. When you create a Universal app solution in Visual Studio, the solution will contain three projects: a Windows 8.1 project, a Windows Phone 8.1 project, and a shared project. The purpose of the shared project is to share code, resources, and other assets such as images between the Windows project and the Windows Phone project. If, for example, I drop an image into that shared project, I can then refer to that image in XAML in the Windows project or the Windows 8.1 project. Similarly, any C# source code files that I include in the shared project get compiled and built into the Windows project and the Windows Phone project. The shared project itself is a headless project. That is, it doesn't pertain to any particular platform. Its sole purpose is to serve as a container through which you can share code and other resources with the Windows and the Windows Phone project. If you have platform-specific resources that you want to use in a Universal app, maybe there's an image that you're only going to use in the Windows app but not the Windows Phone app, then you would simply add that image to the Windows project rather than to the shared project. One of the important things to realize about the shared project is that while you can use it to share files, even source code files, you cannot use it to share assemblies between the other projects. Let's say you have a portable class library, a special assembly, that was built so that it could be used by both Windows and Windows Phone. And you want to use that portable class library in both the Windows project and the Windows Phone project in a universal app. You cannot do that by adding a reference to the PCL to your shared project. A shared project doesn't even support assembly references. So what you would do instead is add a reference to that PCL both to the Windows project and to the Windows Phone project. Then, when you build that universal app solution, that portable class library and everything in it will be available to both of the projects. Universal apps are possible because of the common APIs that are shared in Windows 8.1 and Windows Phone 8.1. The WinRT API, which forms the basis for Windows Store apps in Windows, is present almost in its entirety in Windows Phone 8.1. A lot of developers don't realize it, but Windows Phone 8 was the first version of the phone to include WinRT. Unfortunately, only about 20% of the WinRT APIs present in Windows were present in Windows Phone 8. The big news in Windows Phone 8.1 is that almost all of WinRT has been brought over to the phone. This means that almost any code that you write for Windows will just work on Windows Phone. It will compile and build and run just the same. There are some exceptions. There is still a need at times to write platform-specific code, but what you'll find with universal apps is that that is the exception rather than the rule. Now, just for informational purposes, I put this little chart together here just to give you an idea of the surface area of the APIs that the two platforms share in common. You can see they share a lot more in common than they don't. On the left-hand side, you see some of the namespaces in the Windows version of WinRT that are present in Windows but not in Windows Phone. Not surprisingly, on Windows, for example, we find namespaces containing types that allow us to deal with scanners and printers and other devices. Those APIs are not present on Windows Phone, in part because they just don't make a whole lot of sense there. On the right-hand side, you can see some of the namespaces that are present in WinRT for the phone, which is sometimes informally referred to as WinPRT. And you can see there that there are, for example, types for dealing with Microsoft Wallet present on the phone that aren't present in Windows. What's cool about this is these namespaces that you see here represent just a fraction of the total namespaces in WinRT, with the effect that, once more, most of the code you write for one of these platforms will just work on the other without modification. As we go through this presentation, I show you examples. You'll see how much of the code that I write will work on both platforms. You're also going to see some specific examples of why and when you might need to write some platform-specific code for a particular device. So let's see what it's like to create a simple universal app. I'll start with Visual Studio. I've already installed Update 2 so that I have access to Universal App Solutions, and I'll ask it to create a new project for me. And because I have Update 2 installed, I see a template for Universal Apps, and I can choose from any one of these project types here. To keep things simple at first, I'm going to choose the simplest template, which is the blank app template, and we'll just call this thing First Universal App or something like that so that we know what we're looking at if we go back to it later on. So First Universal App, we'll click OK, and we'll let Visual Studio do its thing. Now, in a moment in the Solution Explorer window, you're going to see the solution appear, and not surprisingly, you'll see that inside that solution are three projects. The first one, called First Universal App.Windows, is the Windows project. When this solution is built, and therefore this project is built, a Windows 8.1 AppX will be produced. The second project is called First Universal App.Windows Phone. This is the Windows Phone project, and when it's built, it will produce an AppX for Windows Phone 8.1. The third project is called First Universal App.Shared. This is the shared project which you use to share code and resources and other things. And because I chose the blank app template, there's not much in that project right now other than an app.xaml file with an accompanying app.xaml.cs. This app.xaml and app.xaml.cs file will serve both the Windows and the Windows Phone project. In other words, when I build this solution, it's just as if those files were part of the Windows project and were part of the Windows Phone project. Now, I'm going to go into the Windows project and open mainpage.xaml. Because I chose the blank app template, this is a simple Windows project which contains just one page. Of course, we could always add pages later on, but let's just get something up on the screen so we can see this thing run. Visual Studio, as usual, has started me off with a fairly rudimentary template. It's a blank page containing a one-row, one-column grid. And just to get something up there, we're going to declare a text block. And let's set its text equal to Hello Windows because we are working in the Windows project here. And let's go a little bit further. If we want this to be centered up nicely, we'll set the horizontal and vertical alignment properties of this text block to center. And while we're at it, because the default font size in a Windows Store app is rather small, we'll set the font size to something that's a little bit bigger so that we can see this. And I'm just going to try 72 to see what that produces. So at this point, let's launch this thing in the debugger. Because the Windows project is the current startup project, if I ask Visual Studio to start debugging, we should see a Windows Store app run. And if everything went well in my typing there, then when it runs, we'll see Hello Windows appear in the middle of the screen. So here is one half of our universal app. This is the Windows 8.1 half. With that, let's go back to Visual Studio. And let's make the Windows Phone project the startup project. So I'll right-click it and select Set as Startup Project. And if you look at the Windows Phone project, you'll see that it's structured similarly to the Windows project. Like the Windows project, it has a mainpage.xaml, and like mainpage.xaml in the Windows project, we're presented basically here with a blank canvas by Visual Studio. So let's get some real estate here by shrinking this down just a little bit. I'll ask Visual Studio to fit that in there. And let's go back over to mainpage.xaml in the Windows project and grab that text block. I'll put it on the clipboard so that we can paste it into the Windows Phone project. Now, you can see from the design preview window here, it looks like that text isn't going to fit, so we're going to shrink the font size down just a little bit. We'll say 36. And let's change Hello Windows to Hello Windows Phone. And we'll also tell the operating system or tell the XAML runtime to wrap that text if it doesn't quite fit inside the window. So I'll set the text wrapping property to wrap whole words. That way, just in case it doesn't fit, we won't see parts of it disappear on the sides of the screen. Now, I'm going to ask Visual Studio to launch this app in the debugger again, and because we've made the Windows Phone project the startup project, we're not going to see a Windows Store app launch. Instead, we're going to see the Windows Phone emulator launch. Now, if you're familiar with the Windows Phone emulator, you know that right now it's booting an image of Windows Phone 8.1 in a virtual machine. It takes just a moment to do that, but of course, once it's up and running, we can leave the emulator running so that subsequent launches will be much faster. And here we see what this universal app will look like if it is run on Windows Phone. This is a very simple application, and yet it demonstrates one of the key principles of universal apps. The Windows project and the Windows Phone project each has its own mainpage.xaml file. The reason is so that you can easily tailor the UI to the type of device that it's going to be running on, specifically to the screen size of that device. The Windows app is going to be running on desktops and tablets. The Windows Phone app is going to be running on phones, which tend to have smaller screens. You may want to lay out your UI elements one way in Windows and another way on the phone. The whole point is you can optimize the UI for the form factor on which it will be running. It turns out it's not a requirement that each project has its own XAML files. It's perfectly acceptable to put XAML files in the shared project and share them between the Windows and Windows Phone project, and sometimes that's very appropriate. In fact, I'm going to show you how to do that later. For now, let's get out of the debugger and let's do a little bit more in this simple application. The shared project as created for us by Visual Studio includes an app.xaml file and a corresponding app.xaml.cs file. But remember, we can add virtually anything to that project so that we can easily share it between the other two projects. Let's do this. I'm going to import an image into the shared project. Say add existing item, and I'm going to pop over to another location on my hard disk here to grab a certain image file. So let's go into right here and in the assets folder right there, I'm going to grab this file named wood.png. Now what I want to do is I want to put a wooden floor type background on this app, both on the phone and in the Windows app. So we currently have the phone project open. Let's do this. I'm going to walk up to this grid right here and use the property element syntax to assign something to the grid background. And that something is going to be an image brush object, which references that image that I just added to the project. So we'll do wood.png, and you can see in the design preview window what this is going to look like on the phone app. But let's take this exact same XAML here and let's paste it into mainpage.xaml in the Windows project. Now we already have a background on the grid in the Windows project, so we'll need to get rid of that to avoid XAML parsing errors, but now we should be able to put that same background on there. So right now, since we still have the Windows Phone app as the startup app, if I go to the debug menu and say start debugging, we should see the new version of this app launch in the Windows Phone emulator. And there it is, and you can clearly see that wooden background. Now let's get out of the debugger once more, and let's make the Windows app the default app, or the startup app. And once more we'll launch this in the debugger. We should see the Windows Store version of this app run now, and it too should have a wooden background. So again, a very simple example, but it does demonstrate that by dropping an image into the shared project, I can reference that image in the other projects as if it were part of those projects. And that is the whole point of the shared project, to make it very, very easy to share code and other resources between the Windows project and the Windows Phone project. In a moment, we're going to look at some more sophisticated universal apps that share code and other resources through the shared project. Before we do that, we need to talk about what you do if you need to include some platform-specific code in that shared project. Remember that both Windows 8.1 and Windows Phone 8.1 implement the WinRT API. So to a large extent, code you write for one will just work in the other. But there are certain types that you can only use in a Windows project and certain types that you can only use in a Windows Phone project. What if you need to use those types in code that you've added to a shared project, but you need to make sure that it only compiles in the Windows project or the Windows Phone project? There are two ways in which developers generally address this. The first and most common is the #if statement. In the Windows project that Visual Studio created for you, it predefined the symbol Windows_app. Similarly, in the Windows Phone project, it predefined the symbol Windows_phone_app. This means that in code in a shared project, you can enclose code that is specific to Windows or specific to Windows Phone inside #if blocks that test for these symbols. #if is great for small blocks of code, but it can grow unwieldy pretty quickly for larger blocks of code. There is another technique that developers sometimes use, specifically when they have longer sections of code they want to include in the shared project that are platform specific, that relies on partial classes and partial methods. I'll show you what that technique looks like in code in just a moment, but first let's see how #if is used to enclose small blocks of platform specific code. Using #if is simplicity itself. All you have to do is enclose blocks of platform-specific code in #if statements like these. In this example, the code inside #if Windows app will only compile into the Windows project, and the code inside #if Windows Phone app will only compile into the Windows Phone project. You can even, if you wish, enclose using statements in #if statements like these. Another way to include platform-specific code in a project is to use partial methods. This is a technique that my friend and colleague John Garland blogged about recently at the URL that you see at the bottom of the slide. The basic idea is this. In the shared project, you implement one half of a partial class. And in that partial class, you implement a public method that can be called from the Windows project or from the Windows Phone project. In that public method, you call a partial method. The reason for the indirection here is that a partial method can't be public. It can, however, be called by a public method. You then go into the Windows project and the Windows Phone project and implement the other half of the partial class. And in those implementations, you implement the partial method, which in this case is called do something platform specific. Here's how the other half of the partial class is implemented in the Windows project. You'll notice that I've provided the implementation of the partial method do something platform specific, and then inside that method, that's where I place the code that is specific to the Windows version of WinRT. I can now do the same thing in the Windows Phone project, implement the other half of the partial class there, and provide a platform-specific implementation of the partial method. So let's go into Visual Studio and see some of these techniques at work. I want to begin with an app named Contoso Cookbook Universal, which you see right here. Contoso Cookbook Universal is a universal version of an app I originally built for Microsoft a couple of years ago to help developers learn how to write Windows Store apps. The universal version has been updated for Windows 8.1, and since it is a universal app, it runs not only on Windows but on Windows Phone 8.1 as well. Before we go under the hood to see how it works, let's see what it looks like from the outside. Currently, the Windows app is the current one, so when I do a start debugging, I should see the Windows Store version of Contoso Cookbook run. It is a canonical 3-page navigation app. On the home page here, you see a hub control listing different recipes and different recipe groups. If I click on one of these recipe groups, like Italian, that takes me to a page that shows all the recipes in that group. And if I click any one of the recipes, we'll just take this one right here, it navigates me over to a page which shows the details of that recipe. Now, that's the Windows version. Let's go back to Visual Studio, shut down the debugger, and let's make the Windows Phone app the startup project. So I'll ask Visual Studio to debug again, and this time we're going to see the phone version of Contoso Cookbook come up in the Windows Phone emulator. And here, again, we see a 3-page navigation app. Once more, we're using a hub control. The hub control is present in Windows 8.1 and Windows Phone 8.1, by the way, which allows me to scroll sideways to see other sections of the hub. So here are the Chinese recipes, the French recipes, and so on. And once more, if I click one of these recipes here, say French macaroons, it navigates me over to a page that shows the details regarding that recipe. And one thing you might notice here is how I've tailored this page's UI to the form factor. In the Windows version of this app, I used a more horizontal layout. In the phone version, I use a more vertical layout so that the user can scroll vertically to see the ingredients, the directions, and other things that make up that app. Let's go back to Visual Studio and take a look to see what makes this tick. First off, I began this project by creating a new universal app solution in Visual Studio. This time I didn't use the simple blank app template. Instead, I used the one that gives me a 3-page navigation app. Here's the Windows project right here. Here's the Windows Phone project, and here's the shared project containing all the shared code and assets. And one thing you'll notice here is that there's a lot more in the shared project than there was in that simple app we looked at a few moments ago. For example, in the shared project's Commons folder, we see a bunch of C# source code files containing components that are used in both the Windows project and the Windows Phone project. In the data model folder, you see additional C# source code files, in particular one named recipedatasource.cs. This is a file containing a bunch of C# classes that model my data, that model recipes, recipe groups. It even has methods that I can call to go load the recipe data either from local resources or from the web using Azure. If you look through here, you'll see there's also an images folder with all the images that pertain to these recipes. If the user elects to load the data locally rather than from Azure, which might be useful if you're demoing this app and you don't have an internet connection, these images are used. And there are a few other things in here as well. But let me show you something here. Let's go into app.xaml.cs. Now, I haven't made any substantial changes to this file. I have added a few things, which I'll show you in just a moment. But if you look through it, you'll see that there are some pound if statements. For example, here's a pound if statement that says, when this is compiled into the Windows project, include this using statement. And when this is compiled into the Windows Phone project, include this statement right here. Now, one of those was added by Visual Studio, this one. I actually added this one right here, and the reason I added that one is this. If you look a little bit further down here in app.xaml.cs, you'll see a pound if Windows app block. So everything inside here is code that will only compile in the Windows project. In fact, if I removed that pound if statement but left the code in there, you'd find that the solution would no longer compile because this code will not compile into the Windows Phone project. What is this code doing? Let me show you. Let's go back to the Windows version of this app and take a look at its settings UI. So once more, I'll make the Windows app the default one. I'll launch it in the debugger. And if I bring out the Charms bar while this app is running and select Settings, you see the System's Settings pane. In that pane, the system provides the Permissions menu item, but I provided the About and Preferences menu items. If you click the Preferences menu items, I show a settings flyout that allows the user to specify whether the data is being loaded locally or from Azure. Again, my thinking here was that if I'm demoing this app in a setting in which I don't have an internet connection, it's going to be useful to be able to load all the recipe data and the recipe images from a local data source. If I want to toggle that, I can just toggle the toggle switch control that you see right there. Now, let's go and look at the equivalent settings UI in the Windows Phone app. Those settings flyouts that I was using there don't exist on the Windows Phone. It's not a UI paradigm that's used. What we do on the phone is something different. So once more, let's make the phone project the startup project, and we'll launch this thing in the Windows Phone emulator again. And you may have noticed that at the bottom of the phone screen here, I have a command bar. If I display it, there's a settings button in the command bar, and clicking that actually navigates me over to a page. In the absence of settings flyouts in Windows Phone, I elected just to build a separate settings page. I used a lot of the same XAML in it that I used in the settings flyout in the Windows app, and I used the same toggle switch control to allow a user of this app on the Windows Phone whether to load the data locally or remotely. But that's why we have in app.xaml.cs this pound if statement right here. This is the code in the Windows app that adds the About command and the Preferences command to the settings flyout and specifies what handlers are called when those commands are selected. Again, this code won't even compile into the Windows Phone project, so by enclosing this code in pound if Windows app statements, I was able to make sure that it only compiles into the Windows project. There's something else I'd like to point out about this app. If you look in the Windows project, you'll see pages named hubpage.xaml, which is the home page, the one that shows up when the app starts, itempage.xaml, which is the one we use to show individual recipe details, and sectionpage.xaml, which shows recipe groups. In the Windows Phone project, you find the exact same files, here representing the same pages in the Windows Phone app. Because we have different XAML files in the two projects, we can tailor the UI for each of those pages to the individual form factors. If you look inside these XAML files, you'll see a lot of similarities in both versions of hubpage.xaml, for instance. I use a hub control to present a basic UI, and that works because that control is present on both platforms. But in other instances, you'll see some pretty interesting differences. For example, in itempage.xaml in the Windows project, I place stack panels in grid columns to create that horizontal layout for the recipe detail that you saw in the demo. If you look at the same page in the phone project, it's similar but not identical. I'm still using stack panels, or at least one stack panel, but this time I've put them in a scroll viewer, and the XAML here creates that more vertical layout that you saw, in which we see the recipe image at the top, the description underneath, and the directions and the ingredients underneath that. So great example here of how having the same page implemented differently in the different projects allows us to take similar XAML but adapt it to the form factor so that it looks great on a Windows Phone, it looks great on a tablet, or it looks great on a desktop. Contoso Cookbook Universal is a great place to start if you just want to examine some source code and wrap your head around Universal Apps. And of course, it and all the other apps that I'm presenting in the session can be downloaded from the link underneath the video. So let's talk about the different ways to share code between your Windows and Windows Phone projects. One way to do it, something you saw in Contoso Cookbook, was C# source code files that I had simply added to the shared project. At build time, those C# source code files get compiled into both the Windows and the Windows Phone project. But what about binary sharing of code between the projects? Can you do that? Can you share an assembly between the projects? Of course. I mentioned earlier that you can't add a reference to an assembly to the shared project, but you can add references to those assemblies to the individual projects, the Windows and Windows Phone projects. Now, not just any assembly can be shared. If you're going to build an assembly that you want to use in both projects, it needs to be either a portable class library, better known as a PCL, or a Windows Runtime Component project. PCLs have been around for a few years now. They're a mechanism that developers can use to build assemblies that can be used in Windows and Windows Phone. And Windows Runtime Components go a little bit further. Not only can they be used in both projects, but they can be called not only from C# but from JavaScript and other languages as well. There's another technique that's useful sometimes when it comes to sharing code, and that is the MVVM, or Model View View Model pattern. If you're familiar with MVVM, it's a very popular pattern among XAML developers, and it lends itself very well to sharing code between projects because in MVVM we can build our model classes and our view model classes in C# and then drop those source code files into the shared project so that they're equally usable in the Windows and Windows Phone projects. Sharing source code files between projects is a simple matter of adding those source code files to the shared project, as you saw in Contoso Cookbook. Remember that any source code in these files has to be compilable in the Windows and Windows Phone project, but you can always use #if statements or partial classes if you want to include platform-specific code in those source code files. If you have a portable class library assembly that you want to use in both the Windows and Windows Phone projects, simply add references to it in both the Windows project and the Windows Phone project. In the example you see here, I've added a PCL assembly named mycomicreaderuniversal.controls. It's the same assembly being used in both projects, but you can see that I've added the references individually to the Windows project and to the Windows Phone project. With the MVVM pattern, the basic idea is to include C# source code files, or assemblies if you prefer, containing classes that are used in both the Windows and the Windows Phone projects. If you, for example, implement model classes and view model classes and drop them into the shared project or share them through assembly sharing, then you can reference those view models and the model classes from the code that you build into the views in the Windows and Windows Phone projects. To demonstrate these techniques, let's look at a couple of universal apps. The first one is My Comics Reader Universal. I'm going to run the Windows version of this first so you can see what it looks like from the outside. And this is an app that catalogs my personal comic book collection. When I was a kid growing up in the 1960s, I loved to read Superman and Batman and Spider-Man and Fantastic Four and all that. And I bought a lot of comic books, which I still own most of today. And I built this app to catalog the collection. It's a basic 3-page navigation app using a grid view control. Here on the home page you see me scrolling through the different types of comic book titles. If I click one of the titles, that navigates me to a page which shows all the comic books of that title. And I'm using a custom control here, a cover flow control, to present this information to the user. If we see a comic book we like, we can click it. That navigates me over to another page which shows a detail of that comic. And just for fun, I set it up so that you can click the comic book cover and it spins around so that you can see the back like that. Now that's the Windows version, so let's go back to Visual Studio and run the Windows Phone version to see what it looks like. So we'll make the phone version the startup project, and once more I'll launch this in the debugger. So in a moment we'll see the Windows Phone emulator come up. And I've elected to use a similar but different UI. Instead of using a grid view control for the home page as I did in the Windows app, I elected to use a list view control, which provides this vertical scrolling experience that you see right here on the home page. So if we scroll down until we find a title we like, let's go to Fantastic Four like we did in the Windows app. That navigates me over to a page that uses the same cover flow control, by the way, to present the comics of that type to me. And if I click one of those comic book cover images, it navigates me over to the detail page, which shows me a detail of that comic, and once more allows me to tap it or click it to flip it around so that I can see the back of it. So let's get out of the debugger and take a look at the structure of this app. For one thing, you'll notice that in the shared project, as with Contoso Cookbook Universal, I have a lot of C# source code files containing classes and extensions that are used in both the Windows and Windows Phone project. Even my model classes like Comic Data Source, which contains the classes that model the comic books and the comic book groups and contains logic for going out to Azure and downloading all the comic book data, all of that is right here in this class. I originally developed that for Windows and was actually somewhat surprised when I just dropped it into the shared project and it worked literally without a single source code change in the Windows Phone. Now, you may have noticed that there are not 3 but 4 projects in this solution. There's a Windows project, a Windows Phone project, there's a shared project, and there's one named mycomicsreaderuniversal.controls. This is a portable class library, or PCL project. At build time, it compiles into an assembly, and inside that assembly is my custom cover flow control, which is in this source code file, as well as another custom control named Magic Image, which among other things makes it easy for me to flip the comic book around so you can see the back of it, and then to flip it back to the front if it's tapped or clicked again. Once more, I originally developed these custom controls for Windows and found, somewhat to my surprise, that in Windows Phone 8.1 they just worked without any modification. Now, I have those custom controls in the PCL project. I want to reference that PCL assembly in the Windows project and the Windows Phone project. Once more, you can't add those references to the shared project, but you can add them to the Windows and Windows Phone projects. In fact, if you look under references in the Windows project, actually that's right here, you'll see that there is a reference to, and let's move this out so we can see it, mycomicsreaderuniversal.controls, that's the PCL, and you see the exact same reference in the Phone project right here. So open up the Phone project, go to References, and there is that reference again. So the whole point here is that we have an app that presents to the user a comic book collection. It's a universal app, so it runs on Windows and Windows Phone. And a lot of the core UI is provided in the form of a pair of custom controls, which I built into a portable class library and then referenced in the Windows and Windows Phone projects so that I could use them just like the built-in controls. Here's another universal app that you might find interesting. It's called Contoso Weather Universal. When I run it, the Windows version that is, it'll present a UI to me in which I can enter a zip code or some other location identifier like the name of a town and a state, and it'll show me the current weather at that location. If I type in zip code 37934, for example, which is where I live just outside of Knoxville, Tennessee, it shows me that it's currently 85 degrees Fahrenheit in Concord, and if I click the More button here, it navigates me over to a page that hosts a web view control that shows richer and more detailed information about the weather at that location. In the Windows version of this, I also provide a list view control with a list of about 100 of the world's major cities, and if I click one of these, like Hong Kong for example, it will show me information about the current weather conditions at that location. Now, that's the Windows version. Let's take a look at the Windows Phone version. So we'll go back to Visual Studio, make the Windows Phone version the startup project, and then I'll launch this thing in the debugger again. This time we'll see it in the Windows Phone emulator. You'll see a similar but slightly different UI. I elected not to provide the list view control with the list of major cities here, but you could still do this. You could say Redmond, Washington, for example, and when you click this button, we should find out that it's currently 64 degrees Fahrenheit there, and once more, if I click the More button, it would navigate me over to a web view page that shows more information about the weather at that location. Now, this app is a full-blown MVVM app. If you look in the shared project, you'll see lots of helper classes that are used in both projects, but you'll also see view model classes. The detail view model is the view model for the page that shows the richly detailed weather information, while main view model is the view model for the main page, the one in which you enter a location and click the button to get the weather there. So if you look through this main view model class, and I won't spend too much time on this, if you've built MVVM apps before, you know what to expect in here. I basically have a bunch of public bindable properties that I can bind to over in the view to present information to the user. Because I've put these view models in the shared project, well, they get compiled into both the Windows and Windows Phone projects and run there. Now, in this case, I didn't need to do any pound ifing, but had I needed to do something platform specific in any of these view models, of course, I could have done that using the pound if technique. What about the views themselves? Well, you see that each project has a main page.xaml. There it is in the Windows Phone project, here in the Windows project, and a detail page.xaml. Because I'm using MVVM, if you look in the code behind for those pages, you'll find that there's not a lot there. There's a little bit of logic there, which is there to handle PLM, process lifetime management, to make sure that if the app gets suspended and terminated, I can restore it back to its previous state when it's relaunched. But other than that, I have all of the logic over in the view model rather than the view. And if you look inside any of these views, you'll see lots of binding statements like this one right here and this one right here, binding to properties over in the view model. So once more, if you like the MVVM pattern, and many XAML developers do, it lends itself very well to universal apps because you share the view models and other classes, the command classes, etc., through the shared project, and then just reference them in the views in the Windows and Windows Phone projects. Normally, when we think about the shared project in a universal app, we think about sharing code and images and other assets with the other projects. But you can share views or XAML files through the shared project as well. In other words, you don't have to have one main page.xaml in the Windows project and another in the Windows Phone project. You can have one main page.xaml in the shared project and use it as a page in both the Windows and the Windows Phone projects. When you do that, it's sometimes useful to know how to measure the available screen size at runtime in case you want to make programmatic changes to the UI based on the form factor that you're running on. It's also useful to know how to structure your XAML so that you can make minor differences in the UIs even though you're sharing that page between two projects. One way to measure the available screen size at runtime and ensure that it works in both Windows and Windows Phone is to do what I'm doing here. I take the root layout element in my XAML, which in this case is a grid. I wait for it to fire a loaded event, and then I read its actual width and actual height properties. In Windows, this will basically give you the size of the screen since every Windows Store app starts off running full screen. On Windows Phone, it won't necessarily give you the actual screen size. On the phone, there may be other elements on the page that subtract from the space that you have available. For example, if there's a command bar present at the bottom, you need to factor in the real estate that you lose to it. This technique, again, will work on Windows and Windows Phone, and on the phone, will factor in elements like system trays at the top or command bars at the bottom that represent unusable space to your application. Another technique that XAML developers often use when they're sharing views between Windows and Windows Phone projects but want to tweak the UIs for the individual platforms relies on external style sheets. Here's a snippet of XAML from the shared app.xaml file, and in it I use a resource dictionary element to refer to an external style sheet named styles.xaml. I can then build two versions of styles.xaml, one for the Windows project and one for the Windows Phone project, and I can define the same resources in each, but I can give those resources different attributes. In this example, in the Windows project, I'm defining a data template which contains a text block whose foreground color is red, while in the Windows Phone project, I'm defining a data template containing a text block whose foreground color is yellow. Notice that I've given both of these data templates the same X key, item data template, so that I can refer to it by that key from my Windows and Windows Phone projects. In the shared XAML file that serves both projects, I can then refer to that data template using its resource ID as you see right here. In the Windows project, this will give me the red foreground color that you saw in the previous slide. In the Windows Phone project, this will give me the yellow foreground color. Let's look at an app that uses a shared view to provide a UI both on Windows and Windows Phone. The app is called Unilife. It's a Windows adaptation of John Conway's famous game of life, in which you draw patterns of cells, as I'm doing here, and then you use Conway's genetic algorithms to evolve those cells from one generation to the next. If I go to the command bar, I can click the Step button to evolve the grid one generation, or I can click the Start button to start a simulation running. Now let's stop that simulation. Let's go back to Visual Studio and let's see what the Windows Phone version of this same app looks like. We'll see the app in a moment in the Windows Phone emulator, and the first thing you notice is that the view or the page looks very similar to the one in the Windows app. In fact, these XAML rectangles representing grid cells are the same size as they were in the Windows app, but due to the smaller screen size, I'm showing a smaller grid. Functionally, the app is just like the one that runs on Windows. I can draw patterns of cells like this. I can click the Step button in the command bar to evolve from one generation to the next, and I can click the Start button to start a simulation running. Now let's take a look at the structure of this project and see how it differs from the other projects that we've looked at. The first thing you'll notice is that neither the Windows project nor the Windows Phone project has a XAML file. Instead, the one and only page in this app, mainpage.xaml, is in the shared project. If you open that file, you'll find that there's not a lot there. There's an empty grid at the root of my layout. This is the grid that I use to position all of those rectangles, but initially that grid is empty. There's also some XAML at the bottom that declares the command bar. This exact same XAML works on both Windows and Windows Phone thanks to the convergence between the platforms. But as you can guess, a lot of what happens here that's interesting happens in the code behind for the page. So let's look at mainpage.xaml.cs. And if you look in this method right here, which I call initialize, this is where the bulk of the startup work is done. One of my goals here is to dynamically create the XAML rectangles representing cells in the grid, but to determine how many of them to create and how many rows and columns to position them in based on the amount of available screen real estate. So at startup, I measure the available screen size by measuring the actual width and actual height of that root grid that you saw. Then I dynamically add rows and columns to the grid to serve as containers for the XAML rectangles. It's in this nested for loop you see right here that I create the rectangles and insert one of them into each row and each column of the grid, that is, one cell of the grid. So what you have here is an app whose UI is mostly dynamic. It is one view, one page that's shared between both the Windows app and the Windows Phone app, but at runtime I check to see how much screen real estate I have available and I build the UI based on that. Because the UIs are so similar here for Windows and Windows Phone, there was no need to have separate mainpage.xaml files, especially when that file just has an empty grid that's being filled in programmatically. So the point I want to make here is that having separate XAML files in the Windows and Windows Phone projects is not a requirement. In a case like this where the UIs are similar or even identical, you can share a XAML file through the shared project with the other projects and then write a little bit of code to adapt the UI to the screen size that you find yourself running on. Let's take a moment to summarize what we've learned here. Universal apps or universal Windows apps are apps that run on both Windows and Windows Phone and in the future will run on other Windows devices as well, including Xbox. Visual Studio offers seamless support for universal apps. When you create a universal app solution, you'll find yourself looking at 3 projects, one for Windows 8.1, another for Windows Phone 8.1, and a third project that we refer to as the shared project. Through file linking, any files that you include in the shared project are built into the Windows and Windows Phone project at compile time. The high degree of convergence between Windows 8.1 and Windows Phone 8.1, that is the fact that they implement a very, very large common subset of the WinRT API, means that for the most part, code you write for one platform will compile and work on the other. But there are APIs in each of those platforms that are unique to those platforms, and there are mechanisms available to you to even write platform-specific code into the shared project. One mechanism is the #if statement that allows me to easily throw in a few lines of code that only compile into the Windows project or that only compile into the Windows Phone project. We also learned that we can use assemblies, specifically portable class libraries and Windows Runtime Component assemblies, and share them between the Windows and the Windows Phone project. We learned that while you cannot add references to those assemblies to the shared project, you can add references to those assemblies to the Windows and Windows Phone projects. Finally, we learned that it is not a hard requirement that each project have its own pages or XAML files. When it's appropriate, you can share XAML files through the shared project and, if needed, write code or write additional XAML to customize the UI in those pages for the individual platforms. Universal apps are the future of the Windows platform. Today they run on Windows and Windows Phone. Who knows where they may be running tomorrow? It's a little bit unfortunate that they're referred to as universal apps because that has led some to believe that they're cross-platform, that maybe they run on iOS and Android as well. They do not, but if you use the term universal Windows apps, that better connotes the purpose of these things. That is, in the future, to build apps that will run on any Windows device. I want to reiterate something that I said at the beginning. Because of the WinRT API present in Windows 8.1 and Windows Phone 8.1, today when you build a Windows Store app, it's generally only a little more work to have that app running on Windows Phone or vice versa. So as you design and build apps for either of those platforms, keep universal apps in mind, do a favor to yourself and your users, and make sure that the app runs everywhere.